The loft compound object is the last of what I would describe as the three main spline-based modeling tools in 3ds Max. It's actually a whole lot more complex than either the extrude or the lathe tools, though with that complexity also comes more flexibility. The lofter in 3ds Max actually comes in the form of a compound object rather than as a modifier. The reason for this is that the splines used in a loft are often not kept intact. In effect, they are merged into the compound object to form a new surface. Once merged, they are not lost, but they are not as easily accessed as in a spline modifier relationship. The key reason for the loft being classed as a compound object is because it can be made up of a large number of splines. So the concept of a compound object makes the most sense in this particular case. So just what is the loft compound object? Well, on a basic level, the loft is very similar to the extrude. It simply takes a shape and extrudes it. The difference is that the extrusion does not have to be over a straight line, though it can be if you wish. Also, the cross section of the loft doesn't actually have to be constant, which is a distinct difference to the extrude tool. So, each loft surface is made up from one spline path, along which a number of spline shapes are defined to specify a cross section at that point. However, if your surface only needs to be extruded along a straight line, and with a single profile, then the extrude tool is a much better option, simply because it's simpler and easier to set up. In that circumstance, it wouldn't be prudent to actually use the loft tool, just use the extrude tool, as we outlined in the chapter before last. Because the loft is so complex, we're not looking to cover every single feature of it here. As we look at this tool, you'll see that it has a lot of options and quite some hidden functionality. So what we are going to actually look at here are the main aspects of the tool and how to use it to create objects that you need. And we'll also focus in on some of its more advanced features. So I'm not going to show you every tiny little point, but I am going to show you the main points and the advanced features so you can get the most out of this tool straight away. It'll then be up to you to read the online docs, and that you will find will fill you in on all the minor details of the various areas of the tool. And once again, experimentation is key here. Follow along with me as I create objects here, and then try things out for yourself. Explore the tool, and you'll see how cool a system it really is. So let's start by creating a surface using the loft compound object. And along the way, we'll look at how this tool works and also why it actually has its name. So I'm going to start off here by creating the path for this object. I'm not really particularly worried about what I create here. It doesn't have to be anything spectacular. This is just an example for you. So let me just create a very simple path. Let's just have it here like this. And I'll just go in and edit it so it's a little bit more interesting than it is at the moment. Just convert these to being Bezier, and I'll just edit these handles a little bit more so it forms an interesting shape. Say something like that. And let's have a look at interpolation. We'll turn off optimize because you can see it was optimizing this curve here into a straight line. So we'll leave optimization off in this case. So we now have a path, as you can see. And now what we need is we need some shapes to actually go along that path. So one of the features of this tool is that the shapes have to have the same number of vertices because it has to be consistent along the length of the loft. Now, normally when you create shapes, you would create them specifically so they have the same number of vertices. But in this case, I'm not going to hand build the shapes. To save some time, I'm going to use some of these presets here. But what I'm looking for is 3 different shapes that have the same number of vertices. So I'm going to choose an n-gon, and I'm also going to choose a star. And let me see, what other shape could I use here? I think it's going to be difficult to find another shape here that actually allows us this kind of flexibility. So I'm going to go for another star, actually. Let me just shift drag this over here. I'm just going to press X so I can see my gizmo. Drag that over here, say copy. We don't want it to be an instance. And I'm just going to edit these shapes now so they're interesting, as an example for us. So let's have a look here. We've got 6 points here. This star has got 6 points, but these are the points here, which means it's got these inner points as well, which means it actually has 12 points. Let me make the star a little bit simpler. We'll go for 5 and 5, and that means that this n-gon has to have 10 sides to match. So that now has the same number of vertices as this and this. I'm going to make the star a little bit more shallow, and I'm going to make this star actually quite a bit more extreme. So let me just put this in a point here. So now we've got 3 different profiles, 3 different shapes, which we'll call cross sections from now on. And these are going to be used along different parts of this path here to create a loft surface. So I'm just going to go ahead now and make the loft. I'm not going to actually explain this as I go along, but I'm going to come back and explain all the different points that are actually done here. You'll actually find the loft is in geometry, and it's not in standard primitives, it's down here in compound objects. And you'll see that if I select one of these shapes here, we've got the option to create a loft. Same here, same here. But as an example, let's say we create a box. This is a 3D object, as you can see. And now if I go down to compound objects, you can see I haven't got the option to make a loft now, and that's because this isn't actually a spline. So it only actually becomes active when you have a suitable object to create that type of geometry. So we'll select this path, and I'll click on loft. And that's actually created a loft object. So what I'm going to do now is actually create the surface. So as I said, I won't explain as I go along here. I'll just do this quite quickly. If we go into a perspective view, you can now see the loft surface that we created here. So the first thing you might have noticed is that when I created this loft, that I actually had the path object selected. You have to have just one spline selected for the loft option to become available. And that spline can be of any type. It can be closed or open. Usually though, you'll want it to be a single path, not really a shape, because if you use a shape, you're going to end up with something which is similar to a lathe. But again, this is a valid use of the tool, and you can try experimenting with that. Very often though, when you're creating a loft, it will be a path, and you'll then put shapes along that path to create a kind of cylindrical object that you can kind of see here. An interesting thing about it is that it actually has a non-uniform cross-section as we travel along it, and that's because I defined different cross-sections along the length by using these the features of the tool here. So let me delete this surface that I've just created, and I'll create it again, but this time I'll explain what I'm actually doing as I go along. So let me just select the surface, press delete. You can see that the path is still here. So the first stage is very simple. We just select the path that we want to use. We click on loft, and basically we've created a loft object. You can't actually see the object because you haven't actually added any cross sections to it yet. So at the moment, it's basically a kind of proto surface. It doesn't really have any form to it quite yet. By default, when you start creating a loft, there are 2 rollouts that are open. There's the creation method rollout that you can see here, and also there's the path parameters rollout. And that makes it very quick and easy to build the basic loft very quickly. So the first choices that we have are get a path and get a shape. And when we actually selected the path and clicked on the loft tool here, one of these 2 choices was basically already made for us because we've already defined our path. But if we want to, later, we can actually change the path by clicking on the Get Path button here and clicking on a different path in the scene. And that will then replace the path that we actually have here with a different path. So you can see it's very flexible in that respect. Another thing to notice is that you can see that we've got these radio buttons here, and they give us 3 different options for what we can do when we work with these shapes. You can see that the default option is instance, and that's active because it's the default and best behavior basically. And what that also means is that when we created this surface, the path that we base the surface on is instanced, and that means that the original path is still there, and if we want to edit the path at a later time, we can, and that edit will actually update in our surface. So it's a dynamic relationship, and that means that the loft is actually a procedural surface, and this is something that we'll talk about in a few minutes, but it's one of the really cool features of the loft surface and also 3ds Max in general. You have a lot of these procedural systems, which means that you can actually change things later in a dynamic manner. So anyway, once you have picked a spline and you've clicked on the loft button, you have a potential loft surface. Now you need to choose where a loft shape will be placed along the path by using the path percentage button that you can see here. As you can see, the default value is 0% along the length of the path. And if you're creating a loft with only one shape in it, then that's all you will ever need. You just basically pick a shape, it goes to the beginning of the path, and that shape will be used along the length of the path, and it's all that you need. However, you may have noticed that whilst I created the first loft, that I changed the spinner values to other percentages and then picked shapes at those values. When you do this, you add another shape to the compound object. This shape is based on the spline that you picked, and its initial position is based on the percentage value of the spinner at the time of choosing. You can add shapes at any point along the path, and you can add as many shapes as you need. So if I wanted to add some shapes to this particular path here, I can choose a percentage value by changing the spinner here, and then I can click on Get Shape, click on any one of these shapes, and at that point along the path, this shape will be used as the cross section. Another feature is that we can actually limit our choices to certain percentages along that path. So if I turn on Snap, and as you can see the default value is 10%, that means now that if I change the path percentage, it's going to be based on that value. It'll basically increment only using that value. So you can see I can click down and it'll go to 70, 60, 50, 40. And we can change this value to whatever you fancy as the snap. And now it'll be snapped to values of 2. So if you have a situation where you need to snap to a certain percentage along the path at all times, you can use that particular feature there. So let's recreate the surface that we created a little bit earlier. I'm actually going to turn snaps back on because I want to snap to units of 10. And I'm going to right click on the spinner just to reset it back down to 0. And I'm going to say get a shape, and I'm going to leave this instance option on. And I'm going to pick on the first shape that I want to use here. You can see that instantly you have a surface, and you can see that the cross section along the entire surface is based on the first shape that we chose here. If I go to wireframe view, there you can see the surface. And also what you can see is that currently we have this particular shape is selected, and this is a sub-object of the compound object. This is something that we'll look at a little bit later. It's actually quite hard to see inside the surface at the moment, and that's because we've got a lot of steps in the shape. And we can actually change that. I'll just skip ahead here and go to skin parameters, and I'm going to say optimize shapes. There we go. And you'll have a pretty good idea of what that does based on the chapter where we looked at interpolation and steps. And if you can notice this yellow tick here, that actually indicates the point along the path that we currently have selected. So I'm going to just change this value, and you can see as I change it, you can see this is actually moving here. And I'm going to move up to 50%, instance is turned on, get shape, pick the shape, and there we are, we've now picked a shape halfway along. And if I change to shaded view again, you can see now that the profile, the cross section has changed halfway along. And if I change the value here to 100%, I'm going to say get shape, and I'm going to pick this shape here. And as you can see, we're back to where we were earlier with our surface again. At this point, let me just show you what these 3 features here do. And for that, we need a copy of these. So I'm just going to hold down Shift and copy these up here. And I'm just going to delete this surface once again. Very easy to recreate it. And let's try creating it using some of those options. So let's go in here, click on Loft. I'm going to change it to Move, and I'm going to say Get Shape is at 0%. And let's just check on this one here. And you can see when I clicked on it, it disappeared. So let's actually see what happened here. If I move this surface, you can see that it's not here either. So what that actually does is it basically merges that shape into the object, into the loft surface, effectively deleting it from the scene when you click on it. From that point on, the shape only really exists inside the loft surface. This can be useful in certain circumstances where, if you can imagine, you've created a large number of shapes and you basically want to add them onto a loft. And as you do so, you want to delete them to ensure that you've actually added that particular shape into the loft. Think of it as a kind of reminder that, you've actually just done something. Now, it's not always going to be useful, but that's what that particular feature does. So let's just undo stuff here and get back to where we were before. And I'm going to create the loft surface again, change to copy. And let's see what happens now. I'm going to say get shape, pick that shape, and you can see we've got our surface back again. And what I'm going to do now is I'm going to actually alter. Actually, let's have a look here. Yeah, the shape isn't there. It's still over here. But it's basically copied that shape and it's now in the loft. But you can see it's actually left it over here. If we edit this shape, let's try changing the radius. You can see it's not actually doing anything. Let's try changing the number of sides. Well, it's changing, but you can see the loft isn't updating. There's no kind of dynamic link there. So that gives you an idea what that does. It's basically like the first option, move, but it leaves behind the surface. It copies it, but there's no dynamic relationship made between the shape and the loft. So let's try the third option. Let's just delete that. And we'll just click on loft again. And I'm going to say instance, get the shape, and we'll click on here. And you can see again, the shape is left behind. But now what you'll find is that if you edit it, although it's not actually updating in real time, but you can see when you release, the surface is changing. And let's say we change the number of segments here. You can see it actually can update that in real time. So there's a dynamic relationship going on between this shape and this loft. There's a link made. So the shape which is here, the definition of the shape is based on here. It's an instance of it. So again, it's using the procedural system in 3ds Max to allow you to create a link between those shapes. And that happens for as many shapes as you want to have in your particular loft surface. So if we just change the radius here, back to where it was before, we'll just change this to 50%, get shape, add this shape, 100%, and we'll just get this shape here. There we are. If we go to shaded, we can grab the star and we can change the, say, the points here. You can see that's changed. We can change the radius in again. Just pull this in so it makes it nice and small. So as you can see, you've got this dynamic relationship here. We can distort it, let's say. Can't actually see that much difference with it at that point. But there is basically a dynamic relationship going on here. And that dynamic relationship is also in place with the path as well. And to do that, I'm going to actually have to move the surface because it's created on the same spot that the path is created on, as you can see. Now, if I go in and I get this path and I modify it, let's say I grab here, and let me just make this gizmo a little bit smaller. If I go like that, as you can see, the surface is updated. And just make it a little bit more extreme. So basically, you can update the path and the loft surface is going to change in a dynamic manner. It's a fully procedural system. It's really, really cool. So as you can see, you can modify the path to be whatever you want it to be, and it'll just update for you. Let's say I've created the surface and I want to change the shapes. How do I do so? Well, I can go in here and I can say pick a shape using this button here in the path parameters rollout. So we can say pick this shape here. You can see it becomes active when you're over a shape. We know that we have one basically the beginning, the middle, and the end of this object. You can see that currently the shape at the end is active, but if we click here, now it's gone green, and that shows that this shape is now active, or we could click on the beginning. And now that it's active, we can actually change it. We can say get shape, and let's change it to this star. There you go. Or we could change it to whatever we wanted to, really. It's up to you. And we could say pick on here, change it to this one here, pick on the end, change it to, let's say this star here. So as you can see, once you've defined the shapes, you can actually go in and modify the geometry. You can replace the geometry with new shape definitions if you need to. If you don't want to actually select interactively, you can step through the different shapes by using these buttons here. So if I go and click on here, you can see it goes down. That's actually, if you look what the button actually says, is previous shape. This does the next shape. So you can see you can go back and forth basically, up and down the object. If we wanted to at any time, we could always just go in, change the percentage value to say there, get a shape, pick the shape. We've added another definition in there at that point, let's say. And as you can see, we can go up here and we can say grab that here. So we can add shapes at any time that we want to, and it's very flexible in that manner. There's one last thing we really need to look at before we finish off in this chapter, though, and that is how do you change the position of a shape along the path, and how do you remove a shape along the path? Well, the way to do that is you go into the sub-objects of the loft. So you need to go up here to the stack window, open up the sub-objects, and you can see now we can select the path or we can select the shape. So if we went here, you can actually, there's the path. You don't actually have an option for picking the path, there's only one. And what put allows you to do is actually to put that path back into the scene. So let's say you deleted this here, you lost that link. You could then actually create an instance of this path. I believe it's an instance by clicking on the put button here. But in this case, we're going to look at the shapes. So you can see that we can select the shape here, select the shape here, just like it's an object in the scene. Or in this case, it's actually held within the compound object. What I can do now is, you can see it's got the path level here, and I can actually modify it. So you can see I can actually move it after the fact. You can reposition it. And you can see you've got these other tools here for doing various things. Check out the online help to see what they do. But you can see you've also got the option again of putting the shape back into the scene if you need to. Also, if you don't want the shape anymore, if you've got too many shapes in your definition, you can just select it and press delete on the keyboard, and we'll actually delete it from the object. So as you can see, you now have the ability to add shapes along the length of the path wherever you want to. You can have them instance to the original geometry. So there's a dynamic relationship to the original geometry. You can also redefine those shapes at any time just by going into the path parameters rollout, clicking on pick, or actually cycling through them using these two buttons. Once you have a shape selected, you can see it goes green. Then you can click on get shape and then redefine the shape at that point with a different spline. You can also go into sub-object mode, go to shape, and select the shape, and you can press delete to remove it from the object, and you can also reposition it by selecting it and then changing its percentage value. Something you cannot do is, and for me to demonstrate this, I actually need to put some shapes back in here. Let me just go down here a little bit, get shape, just grab that, we'll put it up here. We'll get this shape here. And now if I go into sub-object mode again, you can see there's something which we can't do, which is we can't actually make this percentage lower than the next one down in the organization of the compound object. So you can see that we can move it, but we can't actually move it lower than here, as you can see. And that's true of all of them. You can see it's actually, they're stuck between the shape below them on the path and the shape above them. So there you go, you now basically know how to define a loft surface. You know that you need to select a path, click on the loft button, that creates a potential loft surface. Then you need to define some shapes along the length of the path to actually give it some cross sections to work with. You can give it one cross section and that's enough. But if you want to, you can change the percentage value in the path parameters rollout here, and then you can add some more shapes at whatever length along the path that you want to. You can have, if you wanted to, you could have hundreds of different cross sections. Might not make any sense, but you can if you want to. And you know that later on you can go in and you can change those shapes. You can actually reform them by actually having this dynamic link going on by them being instance. So you can always go in later and change this value here, and this then updates in our mesh. We've got this lovely dynamic relationship going on here. So I'll just flip that in, as you can see. And you can see now why it's called a compound object as well, because it's not a modifier. It hasn't really taken this path and modified it, and it certainly hasn't taken this shape and modified it. This shape is still the same. But what it's done is it's taken all of these objects and combined them together to create a new object. It's created a new compound surface based on all of these shapes working together in unison. So that's it for this chapter. We're going to move on now into the next chapter, and what we're actually going to look at is this rollout here called surface parameters. And we're also going to look at this rollout here called skin parameters. They allow us to define and control how the surface will appear in various ways, and they give us much finer control of the resulting geometry. So let's go and do that now.